So today, we're going to be covering zero phase as also linear, as well as linear phase filters. We'll cover the four types of FIR filters. So just before we begin this, Alex, tell me what the deal is with an FIR filter. What does its H of Z look like?
Well, if we were going to make it H of Z, it would just be the numerator. There'd be nothing in the denominator.
The denominator would be 1, that's right. And so what would an H of Z of an FIR filter, generic FIR filter, look like?
Just a summation, like
that's right,
with negative powers in Z.
That's right. So it'd be a summation from k equals 0 to m of a to the a sub k, z to the minus k. So as an example, might be 1 plus 2 z to the minus 1 plus z to the minus 2. That would be a pretty simple filter, which would have length m of 2. Okay, where are the zeros here? How would you find the zeros? I'm not going to ask you what they are numerically, but Walt, tell me where how you'd find what the zeros are of this thing.
I'm not sure.
Well, what do the zeros mean? Still, Walt, what does it mean when we talk about zeros of a filter?
Where the system outputs a 0?
Exactly. For what value of z is H of Z 0? So if you're given a system that looks like this, what would be the numeric process that you'd go through, still, Walt, to tell me what values of z would make that equation H of Z 0? You don't have to tell me the numbers, but just tell me how you'd go about doing it. If you're not sure, tell me what's throwing you. Is it the z to the minus 1s?
Well, I know what the intuitively what those are doing.
Yeah. So I'll help you out. If you want to find the zeros, you want to solve this equation. You want to solve that equation for z.
Right.
But these z to the negative things are confusing, so you'll multiply both sides by z squared. And does that help you?
Yeah, then you just factor.
Yeah, that's it. Then if you can see what the factors are, you just do it. And if you can't see what the factors are, you throw it in the quadratic equation. So then you'd factor or quadratic equation to find the zeros. And then if we had an IIR filter, if this was divided by some complex denominator, some complex polynomial, you do the same thing to find the poles. We're not going to do that now. I'm just going to ask you, tell me what are the poles of an FIR filter? Nick, for this particular filter, where does it equal infinity? Those are the poles.
Wouldn't there be no poles for this one?
Almost correct. You're almost right. For an FIR filter, you will never have any poles except in one place. If you plug in 0 for z, do you see how this thing is really the same thing as saying 1 plus 2 over z plus 1 over z squared? So if we plug in 0 for z, we'll end up getting things with 2 over 0 plus 1 over 0, and those things do blow up to infinity. So the only poles of a FIR filter will be at the origin. unlike a IIR filter that will have them off the origin. The only place where poles will be for an FIR filter will be right at the origin, and there'll be just as many of them there as you have your M of the filter. So for this particular filter, you'll have 2 poles at the origin. That doesn't count for our capital N though. Our capital N is still considered to be 0.